Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe the channel. Today I will discuss another question of qualitative analysis. Question number 3. Qualitative analysis where reagents are selected for use in a test. The name or correct formula of the elements or compound must be given. At each stage of any test, you are to record details of the following: color change seen, the formation of any precipitate and its solubility in an excess of the reagent added, the formation of any gas. The gas, if in a test any gas is evolved, so just write down the test of that gas for identification. You should indicate clearly at which stage in a test change occur. If any solution is warmed, a boiling tube must be used. Rinse and reuse test tubes and boiling tubes where possible. No additional tests for ions present should be attempted. Question number 3. Half fill the beaker with water and place it on a tripod and gauze. Heat until the water begins to boil, then switch off your Bunsen burner. This is the hot water bath. For a test A1, you will need tolerance reagent. Place a 2-3 cm depth of silver nitrate in a test tube. Add aqueous sodium hydroxide. Please be careful while preparing this test. Aqueous sodium hydroxide drop by drop until a small amount of brown precipitate is formed, and then add aqueous ammonia drop by drop with shaking until the precipitate just dissolves. This is the Tollern reagent. When Tollern reagents is used, ensure that all test tubes are thoroughly rinsed immediately after use. Fa7, Fa8 and Fa9 are organic compounds, each of which contains carbon, hydrogen and oxygen only. It means Fa7, Fa8 and Fa9 are organic compounds. Carry out the following tests on Fa7, Fa8 and Fa9. Use a 1 cm depth of organic compounds in a test tube for each test. One test has been done for you. Add test 1, add 2,4-dinitrophenyl hydrazine. This is a confirmatory test for carbonyl group. Orange precipitate, it means Fa7 contain carbonyl group and Fa8 also contain carbonyl group. Fa9, no visible reaction. Now test 2, add 1 cm length of magnesium ribbon. There is no change in Fa7, no change in Fa8, but effervescence of gas can be seen, or if any if any metal is added and effervescence can be seen, then it is definitely will be hydrogen gas. So effervescence of gas produces pops in flame with lighted spleen. Don't forget to write down the test of hydrogen gas, and with magnesium ribbon always hydrogen gas is produced. Please keep it in mind. If in test magnesium ribbon is given, then definitely will be hydrogen gas is there, and write down with effervescence, write down the test of identification test of hydrogen gas. Test 3, at 1 cm depth of Tollern reagent, no change. No change with Fa7. Silver mirror dark gray solid. Silver mirror you get silver mirror or dark gray solid. Silver mirror and dark gray solid. So test 4, no change. Add few drops of acidified potassium manganate. Place the tube in the hot water bath and leave for a few minutes. No change with Fa7, but Fa8 decolorized potassium manganate from purple to colorless, or purple decolorized the purple solution. Fa9 also decolorized the purple solution. So it means that if with Tollern reagent no change is there, Fa7 definitely will be ketone and Fa8 will be aldehyde. And if magnesium ribbon produces hydrogen gas, then Fa9 definitely will be carboxylic acid. Silver mirror test also appear in the case of carboxylic acid. So potassium manganate decolorized again in case of sulfuric carboxylic acid to a 0.5 cm depth in a test tube. Add a 1 cm depth of aqueous potassium iodide and a 1 cm depth of sodium chloride. This gives the same result as adding iodine and alkali. And you know that alkaline iodine gives yellow precipitate if CH3 along with this compound is present, or if CH3 along with this compound is present. So if there is yellow solution is appeared in this test when we have performed this test. So yellow solution is formed. It means uh, this is ketone triiodoform test. So the same result as it is with alkaline iodine. No change with the, it means it is not ethanol, it is another aldehyde is present, like propanol can be, or butanoic acid as well. So there is also no change. It means there is no CH3 directly attached with the carbon, which is bonded with oxygen. So these tests identify that this solution is this Fe7 is propanone or ketone. This is aldehyde, and this is carboxylic acid. And if there is no positive observation with this test to a 0 cm depth in a test tube, add a 1 cm depth of aqueous potassium iodide and 1 cm depth of sodium chloride. So it is this is propanol, this will be propanol, and this is propanoic acid. So Fe7 contains functional group ketone, Fa8 aldehyde, and Fa9 carboxylic acid. You are provided with a solid Fa5 by carrying out the following test. You will be able to identify 3 of the ions present in Fa5. Place a spatula measure of Fa5 in a hard glass tube. Heat gently at first, then uh, there is no change. Heat more strongly until no further change. Solid turns yellow. Effervescence of gas, which turns lime water milky. It means carbon dioxide gas is there. And allow the tube to cool. Solid turns yellow to white. So first immediately this is yellow, and keep it in mind that zinc oxide zinc oxide when zinc carbonate is decomposed, hot zinc oxide is yellow, and when it is cooled down it will become white. So solid turns yellow and then yellow to white. Now place a test spatula measure of Fa5 in a test tube. The solution is Fa6. Add about a 5 cm depth of dilute nitric acid. You will use the solution formed for test 3 to 5. Effervescence of colorless gas which formed white precipitates with lime water. Solid dissolves to form a yellow solution. Which formed white precipitates with lime water, like that the gas which is produced turns lime water milky. So solid dissolves to form a yellow solution. When you add dilute nitric acid, solid dissolves to form yellow solution. To a 1 cm depth of the solution in the test tube, add a few drops of aqueous potassium manganate, then solution turns orange brown. So it means if solution turns orange brown, then iodine iodide ion must be there, which is produce iodine, which is converted into iodine. So iodide ions are there. Add few drops of starch solution. Solution turns blue black. It conforms iodide. It conforms iodide ion to a 1 cm depth of solution in a test tube, and add a few drops of aqueous silver nitrate yellow precipitate form. This is again confirmatory test of iodide ion. To a 1 cm depth of the solution in a test tube, add aqueous ammonia. White precipitates form, which uh, dissolves in or soluble in excess of ammonia. Use the qualitative analysis notes to identify three of the ions present. So one is carbonate, in which carbon dioxide gas evolved, which turns lime water milky. So it confirms that carbonate ions are present. So with addition of silver nitrate, aqueous silver nitrate, yellow precipitates are formed. It means iodide ions are also there. And to a 1 cm depth of the solution in a test tube, add aqueous ammonia. White precipitate forms, which um, soluble in soluble in excess of ammonia. So it means this test confirmed that zinc ions are present. So three ions are carbonate ions, iodide ions, zinc ions. Okay, so these ions are present in Fa5 Fa6 solution. Okay, so this is all about of this qualitative analysis question. Hopefully you understand.